I'm Engineer Watson, a project design engineer based in Antrim. We're an engineering design consultancy who work within the energy sector. This presentation is on designing the transition from fossil fuels to low carbon technologies. A little bit about project design engineers to start off with. The company was founded in 1989. It's basically we work throughout the UK, Republic of Ireland, and Europe, and we are now part of the Fingal and White group of companies. In Antrim, we have 25 people and an additional 112 throughout Ireland as part of Fingal and White. We're a multidisciplinary engineering team, and we're professional engineers. And the services that we provide are front-end engineering, budgeting and estimating, site support, procurement, tendering, design and construction safety management, detailed design specification drawings, design and build, construction management, and project technical commercial completion. We've also got ISO 9001, ISO 14001, and ISO 45001. As I said, we're an engineering design consultancy, and basically we started really in the oil industry, supporting it, and that was in 1989. But obviously we have seen there's change happening with climate change and environmental legislation. So where we have worked within the oil industry, and we still do that, because it still needs support and still is an important fuel for Ireland and the UK. But there is that transition which is moving across into other projects. So, within the oil industry, we've done everything from minor to major changes to also complete brownfields, seabed upper tier coma oil terminals, which we have constructed and designed 2 of. We have also been heavily involved in the battery energy storage systems, better known as BESS, within Northern Ireland and in the UK. To date, we have had projects which have installed over 220 megawatts, and that's over 7 projects. We also have another 72 megawatts currently in planning for 2 projects, and we are also currently developing 200 megawatts plus of storage throughout the Ireland. We also, as part of the transition to renewable fuels, we have been involved with hydrogen generation, storage and refueling for road transport and fuel cells. PDE has been involved with the hydrogen refueling system, HRS, for TransLink for their buses, and hydrogen generation at Long Mountain for Energia, which is going to be supplying the buses. We're also in the process of developing a number of larger projects, one of them up to 14 megawatts of electrolyzers with 8.5 ton of hydrogen storage, truck filling facilities, and fuel cells for electricity generation. Those are typically the projects that we have been involved in and they're currently working on. But as in all types of engineering, we have seen there's been challenges, and there's obviously advantages going to these technologies. As previously said, we work within the oil industry, but climate change and environmental legislation aims to reduce the dependence on fossil fuels for heat, power generation and transport, therefore developing a low carbon environment. PDE as a company realised that we had to embrace the new technologies as well as support the oil industry. As previously said, the oil industry is still going to be with us for a period of time, and if you consider Northern Ireland, 68% of houses are actually heated by oil, and that's going to take a time period to actually transfer to a renewable source. PDE already had extensive experience working within hazardous areas, dealing with the control of major accidents and hazards, which is the COMA regulations, and some of these skills are transferable to newer low carbon energy technologies. Typically hydrogen is a very volatile fuel, but within proper controlled environments, it can be safely managed. In the battery energy storage systems, which is our first move into renewable fuels, we basically had to reskill and retrain our workforce to look at the requirements of that battery energy storage systems. BESS as technology has challenges of some of the battery chemistries have caused fires, and those have been basically quite a lot of internet coverage on those fires. And this has caused public and consultee resistance to some of these projects, which impacts on planning. This is one of the issues, is trying to get these projects up and running, and some of them have had considerable time in planning, and that's something that I think that needs to be addressed so that these projects can actually get into actual work on a more expedient way. Also, the technology providers are continuously developing the systems to improve safety and efficiency. That is something that the earlier technologies and some of the battery chemistries have had issues with, let's say, fires, but most technology providers now are going for lithium iron phosphate, which is a safer technology, and it basically is a non-combustible technology so that we wouldn't have the potential of fire. BESS also has the advantage of stabilizing the electricity network. One of the issues is obviously seeing large demands coming on the network, and battery energy storage has the advantage that it can be switched on very quickly. It can actually put a load onto the grid, or it can actually put a supply onto the grid. So where there is a peak demand, it comes in very quickly. Typically, storage would be anywhere between half an hour and 2 hours, but it will actually support the grid, therefore no need for actually turbines to actually run up to support it. Same if there is a dip in the actual demand, the actual battery storage can be switched on to charge, therefore stabilizing the grid. Hydrogen is relatively new in the UK and Ireland, and to date we are using US-based guidance and for design and safety reports. Typically that's NFPA 2 versus ISO 19880, and those are developing design codes, and no doubt that the UK and Europe will catch up and will adopt those codes. We would see this as a form of energy becoming more popular with transport and injection into the gas networks. There's also an advantage of harnessing curtailed wind power to generate hydrogen. And we would see this very much for the wind farms. This is a win-win situation. So when they are in a situation where the wind is curtailed and not required on the grid for grid support, that could then be used for powering electrolyzers, which would be for hydrogen generation. That hydrogen generation, as I said, can be used for road transport fuels. It can be used for injection into the gas main, therefore putting a renewable source into gas. And it can also be used then going back into fuel cells, which then can go back into electricity. So we would see that there is a shift, very much so, from where PDE started to where it is today. But as previously we said, we are embracing these technologies. We see this is the future. We see that fossil fuels will ultimately disappear. Timescale, I'm not sure what that's going to be, but we can see with the amount of battery storage. Say to date, we've been involved with 220 megawatts, and there's several hundred megawatts coming behind that. Hydrogen, we can see that it is definitely happening. As say, one of the projects is 14 megawatts of electrolyzers that we're looking at. But it needs to be that those technologies are embraced by consultees and the public, and realize that these can be safe methods of actually providing energy, therefore, in essence, to keep the country moving and also to keep the lights on. That is basically my presentation. And as I say, it is that sort of shift from the fossil fuels to low carbon technologies. These are ever developing very quickly, and they will need to be embraced by the potential users and end users. And also one thing we have to be very wary of is that the rest of the world is doing this as well. And if if Northern Ireland and UK and Republic of Ireland don't actually get moving in these quickly, we're going to end up going further and further down the order list. We are already finding this with battery storage that to try and get expedient delivery of batteries is difficult because there is so much demand worldwide. It's the same as going to be with the electrolyzers. So there's only so many companies who are actually providing these technologies at present. That will obviously expand, but one of the issues is actually being able to get that technology when we need it, so we can get to a low carbon technology energy provision.